Okay, so I'll get underway. Hopefully everyone can see this. Let me know if you can't. Yeah, so we're really happy to launch a series of reports, basically based on some investigations that we've been doing with a number of academics and industry professionals about the sort of gaps between academia and industry, but specifically within energy and data science sort of intersect. So I'll introduce each of the speakers in more detail as we go along, but the point of these talks are really to enhance essentially a lot of the topics that came out of this report. So we've got talks about sort of the code gaps, about collaboration, about sort of reproducibility in research, and also generally some of the misalignments between academia and industry. And so I'll quickly say something about the Catapult, just so you know who we are and why we care about this. We are a sort of part government-funded research organization who focuses on supporting innovators in the energy system. But one of the main aims also is to sort of bridge the gap between stakeholders in the sector. And therefore one of the important bridges is that between academia and industry, and so this is very important to us. Okay. I probably don't need to highlight to many of the people on the call that there is sort of, often some difficulties in getting some of that research in academia and the innovations made there over into industry. There's the sort of famous valley of death, where there's a gap in transferring that knowledge. But in particular, we found that, that the same is true with data science, which might be a bit surprising given, the quite applied nature of a lot of that. As the data science and AI section of the Royal Society said in 2021, when assessing the AI roadmap, they said there was, the knowledge transfer is currently not working. And there's a lot of frustrations between some of the collaborations, maybe are suboptimal, but also there could be better ways to support each other. So we discussed this originally with Arenco maybe 9 months ago, where we found a lot of these challenges that were in the industry. And so we decided we wanted to learn a little bit more about that. So we started interviewing a large number of academic and industry experts. You'll see a big list underneath there, and we want to thank them for all their contributions to this. And we think that we are, as far as we are aware, we couldn't find anything else. And we're kind of one of the few looking at the intersect of data science and energy sector to try and understand, where the gaps are. And this is, particularly important given, our net zero ambitions. And we also did a literature review, which tried to focus on price forecasting, which is one of Arenco's specialties. So we could kind of better understand, where the gaps are from some of these, papers and publications from academia and how they could be applied in industry. What were our final inputs? So with all our interviews, we identified a number of categories, and they could split into sort of two areas. You've got the sort of pink boxes at the top, and that's really about impact. The two main areas of impact that academia can make in industry. That's sort of in the technical knowledge that they can share, but also in the skilled individuals, which can do something towards helping, the skills gap that is emerging in many data science areas, not just energy. And then we found that there was sort of 4 core supporting mechanisms that came out of that, and those are those yellow boxes there. And so we published those reports today. We'll share the link in the chat if we haven't already done so. We encourage you to read through those. There's a lot of material in there, but I'll just summarize a few things that came out of the reports. As I say, one big aspect is accessibility and reproducibility. If you have applied research, that it's very important for academics to try and publish them in open journals, or at least make them in open preprints. But it's also important to have a clear, methodology and make sure that research is reproducible. There's emerging in data science now sort of a bit of a reproducibility crisis with, making sure that these machine learning models can be recreated. And one way to help with reproducibility is sharing your code or saved trained code with the paper, but also making sure you share that with open data and common benchmarks. One of the second main areas as well was collaborations. We'll have a talk on a bit later, but in the specific context of data science and energy systems, we found that there was a misunderstanding between, the two areas. They have very different cultures and objectives, and not always knowing the best way to collaborate as well. And second, also, it's very much a short-term view, looking at individual projects. So we were very, interested to hear from people like Pete, who will be talking later, about the idea of sort of longer-term strategic partnerships. I'm not going to talk too much about code, other than that software skills are a big, a big gap between academia and industry. Sam Hinton, who's our next speaker, will talk about that in a bit more detail. And then finally, about industry support. Since industry is interested in the innovations that come from academia, it's very important, where possible, that they can actively engage with the community and share their data, the important problems they're facing in their industry, and if possible, code. And we found that data science challenges are a brilliant way to facilitate this, because they can frame the problem with the data and possibly some code at the same time. And finally, one of the bugbears of many of the academics we spoke to was that they don't really find out when their research is being used. So, if possible, that industry should maybe give feedback to academics about when their outputs are utilized. Okay, so I'm going to stop sharing now. I'm going to start introducing my next speaker. So maybe Sam Hinton can bring up his talks. I'm very pleased to introduce Sam. So he's been my colleague on this project and working hard with us on writing up these reports. And it's particularly in understanding the gaps between the programming and the coding skills, and some of the needs that innovative data science teams like in Arenco need. I'll give him a brief introduction. So he's a senior data scientist at Arenco, experienced consultant with a background in data science, data engineering, astrophysics research, and software engineering. And he contributes to numerous open science libraries and provides courses in the areas of data and statistics. So I'm very pleased to introduce Dr. Sam Hinton, who will talk on code, the missing link connecting academic publications to industry.
All right. Hopefully everyone can share my screen. Steve, yell at me if you can't. Yeah, thanks for coming, everyone. I'll try to keep this fairly brief. And as Steve said, there's a lot that we cover in the reports. There's only 10 minutes, so I'm going to try and focus really hard on what I think is the largest skill gap between academia and industry, and it is code and coding skills and everything around that area that we could talk about. So, simple breakdown. Is there an issue in coding skills? I'll try to convince you. If you disagree, then we'll fight it out in the Q&A at the end. I'm very happy to do that. Why is there a potential issue? How can we actually help fix the issue? And then I'm going to try to drill home that even if you don't believe there's a very significant issue, there's still plenty of reason to try and upskill specifically students, masters and PhD students in the area of code and software engineering, regardless of its potential use or lack of use within academia. So jumping into things, part of what we did was obviously a range of interviews with academics, with industry, with people that sit between them, just asking various questions about how they collaborate. On the other side of things, we did do a nice little Scopus search, and we grabbed all of the most highly cited papers in the area of price forecasting. We tried to narrow it down, and we reviewed these papers based upon a whole set of criteria, many more than what you're seeing right now. I just zoomed in and took a screenshot on the area that I care most about, which is the code section. So I've removed all of the paper names because I'm not here to point fingers. The only paper that we found that actually did a really, really nice job with code was Largo's review. So this is the one that actually said, look, here are some common implementations. Here are some data sources. It's all on GitHub. It has documentation. Go here and check it out. And apart from that, we really only had a single paper out of the ones we reviewed. So again, there's more. I just haven't put more rows in that offered really any code at all. This was a little bit weird to me because I like reading code. I get a lot of value out of it, and my research background is astrophysics, and there has been a really significant push within the last, I guess, 5 to 10 years to try to make sure that code is treated as a first-class output of research rather than it being second class and the paper being the one that's published at sort of with all of the prestige. So in terms of why it's so useful, I included this iterative column. If we think about a generic price forecasting paper, they might come up with, let's say, some new hybrid method. They might have some data that goes in, do some data cleaning, some feature engineering, a bit of hyperparameter tuning, stick it into their hybrid model, run it across some test data set, apply some picked metric, and then come out and say, look, our method here is great. We beat this other method by 1% or 2% or 400%, who knows? But without the code, it's very rare to see in this iterative column papers that actually break down where all of the value comes from. So how much of the value is the hybrid model? How much comes from the hyperparameter tuning or the feature engineering? If I can't reproduce the paper by running the code and answering those questions myself, if they're not answered directly within the paper, then there's suddenly a whole bunch of work for me if I want to try to take these ideas in academia and apply them in a proof of concept in an industry focus. So that's me in industry as to why I care. But if I take a little step back outside of my industry brain, I care as an ex-academic because I know that the vast majority of my PhD and master's students will not be staying for the rest of their lives in an academic research position. It's common for people, especially people doing, a master's of data science, to leave academia. They take jobs as data scientists or data analysts, or data engineers, and it's so critical to have those good coding skills. If I take another step back and put my academic shoes back on, I have found time and time again that good code, when released with my papers, increases the impact of my papers. And in fact, all of my most highly cited papers are ones that have code either as a direct product or a secondary product for other people to use. That code also has gotten me numerous times collaborators in other academic fields or collaborations and with industry. So it was really useful for me as an academic. And then as a student, it became the source of truth. If I could get code for something, it didn't matter if I didn't understand the weird math that was going on in the papers or various sections. I can read through the code top to bottom. Eventually, that, with the paper combined, would solve all of my questions that I couldn't answer without it. So if there are all of these benefits, why was there so much red on that first table? Why does it seem that most people don't publish code? And I think it's fairly simple. There's a lot of reasons why people don't want to, and they're not easy reasons to just dispel and say, well, just do it better. So people include code generally when they have students or students that have that technical knowledge already, when the barrier for doing so is low. But if you don't have that technical knowledge, if you have to learn what Git is and how all of that works, then suddenly it's a lot of work. It's already normally a lot of work to clean up and refactor code. And why would you do all of this work if there isn't that cultural shift where you treat code as a first-class product? So if having a paper is just as good as having a paper plus code, why do you put the extra effort in? Most people don't. I don't fault them for that. And then as soon as you do publish code, you raise this whole, well, what if someone finds a negative sign that should be a positive sign, or that divide by 2 is actually a multiply by 2? You open yourself up to risk. And then if someone does run the code, even if they don't find a mistake, they might ask you, oh, I'm having issues installing this or that or getting this to run. You don't necessarily want to create a support debt for yourself in the future. So there's lots of reasons not to do it. A lot of them is not being able to publish code well that reduces all of these negatives down to something that is, in my idea, a manageable burden. So how can we change things, both in industry, but mostly as academics, as supervisors or PIs? How can we try to encourage a more code-friendly and code-first way of academic research? Well, I think here's just a few, happy to add more. I have an infinite number of these points, but tackle code early. So I also, as part of this, did a review of quite a few of the Masters of Data Science or similar programs in universities in the UK. And out of all the ones, so around 24 that I found, 2 of them in the Masters had subjects like Introduction to Programming and the rest of them didn't. There's, in general, no focus on software design principles, productionizing machine learning data, which helps with the reproducibility crisis. It's generally, here's some courses that, give you some cool techniques, genetic algorithms, deep learning, but there's very little focus academically and with curriculums and courses on trying to productionize and get code skills improved. So instead, if through our master's programs and our PhD projects, we can instead encourage students to take their time to improve code as you go, rather than get some results out, throw in overleaf your paper, get the paper, and now you have a huge amount of work to do with your code. Instead, foster that collaboration and that spirit of continually improving the code and having code review internally. We demoed this at UQ a few years ago in my group and found that it was a great success. It helped our students a lot. And then we can also apply pressure top down to get journals to embrace code. So Archive recently has their explicit code links. If we can do that for other journals, great. And then in terms of treating code as a first-class product, there are journals like the Journal of Open Source Software that people can use to try and actually publish code and get citations with the code.
One more minute, Sam.
Oh, that's all I need. Okay, so as a final, I really do think this is an actual problem. It's not just me. Here is a report from the UK government. So on the left, top 10 business skills that they need more skills in. Machine learning, obviously, new field, not too surprising, but programming comes second. And then if you look at the table on the right, this is sorted by the gap. So this is only 50% of students think that they're going to have good programming skills in the future, despite employers thinking that 70% of the time they will need strong coders. So it's an identified gap even with our current students knowing what curriculum they have ahead of us. So I think it's up to us, and I say us as people in charge of those courses, to try and make sure that we give students the skills that they need to get ahead in industry jobs. There are plenty of small resources that you can use to try to tackle this program without having to learn everything yourself. Refactoring Guru, cookie cutter data science for project templates, and obviously the Turing Way. And I won't talk any more about the Turing Way because we've got that for you just a little bit later. And that's everything from me. Thanks, everyone. Back over to you, Steve.
Brilliant. Thank you very much. So, Annette, if you want to start sharing your slides, I'm very happy to introduce Dave. Thank you very much, first of all, Sam. That was brilliant. If you have questions for Sam, please put them in the chat. So yeah, I'm very happy to introduce our second speaker, Dr. Annette Bramley, who's from the N8 Research Partnership. So since 2018, Annette has been the Director and Chief Collaboration Officer of the N8 Research Partnership, the strongest university research alliance in the UK. And as one of the UK's foremost experts in research culture, she has become a regular and in-demand speaker on the subject. So in addition, Annette's written a book recently on research collaboration. So we're very excited to have her here today to talk about more than words, why and how what we say helps or hinders collaboration and what we can do about it. Thank you.
Thank you, Steve. Thank you so much. Hi, everyone. Good morning. And thank you to everyone online for being here, and to the organisers, particularly Tabitha, for bringing us all together, and to Steve and the other authors for all the time and effort that went into producing the report that we're here to launch today. I have to say, when Steve asked me to speak about research collaboration between academia and industry, I was like super delighted, because as you can tell already, research collaboration is one of my favorite topics, and I could talk about it for much longer than 10 minutes. It's a huge topic. The report itself has as two recommendations that Steve's already put up, but there's much more detail as well in the supplementary annex that accompanies it. So I can't do the subject or the report justice in 10 minutes. And we've all been to these kinds of events where we've been inspired by the talks and the discussion, and we go away, but nothing much changes. So rather than kind of talk about collaboration in a systemic or theoretical level, I wanted to leave you with some practical hacks, which you can use to improve your approach to collaboration right away. And all collaboration is built on relationships, and that includes collaborations within our family system. So hopefully you'll find these useful right from the word go, and you can start practicing them right away. So I'm going to focus today on what we say and how that helps or hinders collaboration. And why I'm doing that is because this is one of the most common causes of wasted time and effort in collaboration between people of different backgrounds. So today we're talking about academia and industry primarily, but it can be different academic backgrounds. It can be between different sectors. And I'm going to tell you a little story that illustrates this. But before I do, I've got one little task for you. Many of you will have taken part in a Mentimeter poll before, but for those of you who haven't, Mentimeter is a web-based polling software, which you can access via your browser. So I'm just going to ask you to either grab your phone or open your browser and to open up the link there, www.menti.com, and Tabitha's going to put this in the chat. And when you get there, enter the code that's on the screen, 2203719, and input the first thing or things you think of when you hear the word marker. Okay, and while you're doing that, I'm going to tell you a relevant story. And it's about some physicists and some chemists that were trying to solve a problem for an industrial microfluidics production line. So about 6 months passes and into the project, and the physicists were, really happy and contented with how they were, how the project was progressing and the amount of chemical they were able to detect. And the chemists, on the other hand, were concerned the system wasn't sensitive enough. And they were spending a lot more work on improving the sensitivity. And the project had begun to split into two parallel paths rather than one integrated whole, with the chemists putting much more effort into achieving greater and greater sensitivity. And it wasn't clear to the physicists why the chemists were doing this. Why weren't they happy? And the chemists couldn't understand why the physicists were happy. So eventually someone asked, what do you mean by sensitivity? And the definition in physics is the lowest concentration of molecules that can be detected. And the definition in chemistry was the lowest concentration of molecules that could be detected and measured to a certain accuracy. And what's important in this case is whichever definition of sensitivity is important for the application that is required by the company. But it hadn't been clarified at the outset of the collaboration. And because of this, several months' time and effort had been put in to trying to reach two different solutions. And so fortunately, by asking the simple question, what do you mean by sensitivity? The team identified that they'd both been making assumptions about what was needed and were able to sort out the miscommunication. And so after this, the system was modified. They went on to have a working system installed on the industrial microfluidic production line, and they got some excellent publications which satisfied the academics. But nonetheless, there had been wasted time and effort, which had slowed the project down. And that's one of the key points. Now, this is where I hope that you have all been taking part in Menti, otherwise it's all going to look extremely embarrassing. But here we go. Oh, look, here we are. So hopefully you can see here what immediately springs to mind when you hear the word marker. So we've got here some things which relate to pens, whiteboard, highlighter. Then other people have put chemical tracing, genetics. Others have put exams. What else can I see? Examiners. When I've asked this question, I've also, and particularly topical with the women's Euros that's on at the moment, I've had marker in football come up. And I guess what I would like you to take from this is just, even with a simple word like marker, some people could be taking different meanings from that word. And if you haven't clarified that at the beginning, then it may cause you problems later on. Right, and I've managed to switch my screens back, which is just excellent. Right, so I'm just going to move on now. So hopefully I've convinced you of the importance of the words that you use to define a problem. But language is more than that. And here we have some people doing sign language. Language is actually a piece of neural technology that can rewire someone's mind. It's a way to implant a thought from your mind directly into someone else's mind, which hopefully I'm doing now, and they can attempt to do the same to you and without surgery. And I have to credit Professor Mark Pagel from the University of Reading with implanting this idea in my mind during his TEDx talk. So do go and look that up. But for all of its power, language has its limitations and misuses, because if we can't understand the language, we don't understand the words, we can't share the thought, the idea, or the information. And we can't describe our problems, understand the challenges faced by others, an industrial partner. We can't appreciate the significance of a new discovery or the importance of a global crisis. And the fact is, language has a powerful influence, not only as a tool to communicate ideas, but in shaping our physical, mental, and emotional responses to a situation. It also reflects and shapes our cultures, and each of our organizations has cultures, and the culture in academia and industry is also really different. And so you can think of times when you've had the experience of being surrounded by people talking languages you don't understand. And that can feel energizing. If you're on holiday, it can be exciting and energizing, but it can also be excluding, disorientating, and vulnerable. And so if you're a member of the public or someone working in a company that's come in to work on a collaborative research project, and you've never interacted with an academic or a professor before in your life, you might find the idea of universities and academics intimidating or out of touch or in a completely different social class. And if you can't understand what's being said because the language is locking you out of the conversation, how can you come to trust researchers? How can you build a relationship with them which might outlast a single project? How can you properly explain to them the challenges that you're facing and the experiences that you're having? So communicating is not about dumbing down. It's about taking the time and the effort to make sure that everyone can participate equally in a collaborative project. Is about making a very clear statement which says, I want to share the power of my knowledge and understanding with you so that we can work together as equals to find a solution to this situation or a challenge which we both agree is a problem. And it is about laying the foundations for a successful collaborative relationship. So hopefully I've convinced you of the words we use and how we use them. And I promised you some hacks to take away with you. So here's the first one. Number one, slow down. Okay, when we're excited about a project or idea, or if we think we've got the answer even, it's easy to rush headlong in and not take the time to make sure we've understood what, for example, sensitivity or marker means in this context to this company. And if we don't slow down at the start, we might waste time and effort later on. And if we're trying to build a relationship, one that might outlast the project, building the common understanding is the key building block to that. So don't rush it. Right, another one is a picture tells a story. So here we are. My favorite example here is the word goal. So again, do that brief exercise. What does that image conjure up for you? Is it a football goal? Is it a netball goal? Is it a rugby goal? Is it a success? Or something like that, completely not sporting related. As you can see, by using a picture, we can very quickly clarify, for example, whether we want to get the ball between the uprights and above or below the crossbar in order to score the goal. And the third hack is practice, practice, practice. You can help yourself be more easily understood and understand others more easily by broadening your language. And the best way to do that is have lots of low stakes conversations with people from different backgrounds. So by using your language with non-experts, you get much more adept at articulating the concepts. You get to know which ones are more regularly misunderstood and can benefit from a picture. You'll be clearer and more accurate in your choice of words because you'll know which ones can be confusing. And by having lots of conversations with different people, you'll broaden your network and make it more likely you'll find someone you really want to collaborate with. And in low stakes environments, it's really easy to ask questions like the really handy, I'm curious, this isn't my field. Could you explain what you mean by whatever? Okay, so I'm basically out of time. Language really is more than words. I don't have time to expand any more in this short talk, but there's loads more in my ebook for the Institute of Physics, which is published by IOP Publishing and available from IOP Direct or on Amazon. I find that completely mind-blowing. If you have access to a university library, you may well be able to download it for free. And thanks for your time, and I look forward to the rest of the discussion.
That's brilliant. Thank you very much, Annette. Yeah, so please put any questions for Annette in the chat. and we'll discuss at the end. And yeah, let's move on to our third speaker. So it's Dr. Alejandro Coca-Castro from the Turing Way. So he's a postdoctoral research associate in data science for the Alan Turing Institute, and holds a PhD in physical geography with a master's in environmental monitoring, modeling and management at King's College London. So in addition to his research at the Alan Turing Institute, Alejandro is the lead of the Environmental Data Science book, an active member of the Pangeo Europe network, and one of the co-leads of the translation and localization team of the Turing Way. So I'm very happy to introduce Dr. Alejandro Coca-Castro, who will be talking on the Turing Way, a collaborative guide to data science and research.
Okay, may I confirm that you see my slide, right? It's okay?
Yep, I
Hello?
can see. Yeah.
Okay.
Great.
Hi, everyone. Thank you for this invite. I'm honored to be part of this discussion about the gap between academia and industry. I've been working with academia a long time, but also involved with NGO and government and industry. Indeed, I was intern at the satellite application Catapult like 3 years ago, and was very exciting to know more about the industry sector. But I am today presenting the Turing Way, and that is a collaborative guide to data science and research. So just to put you some context about the Turing Way, is a project. I am core member of the project, and I as part of my introduction, I also part of the translation team, because I'm speaking Spanish, and I guess one of the barriers that to apply data science is over languages, not only in communicating between sectors, but also our languages where we have communicating English to Spanish or to other languages. But the Turing Way is an open science, open collaboration, and community-driven handbook to data science. We involve support a diverse community to make data science reproducible, ethical, and collaborative for everyone. To make our work truly beneficial for as many people as possible, we collaborate project, but we received some support from the institutes. And for those ones that are not familiar with the Turing Institute, I go very briefly, but it's the National Institute for Data Science and Artificial Intelligence in the UK. We believe that data science and artificial intelligence will change the world. We aim to train the next generation of leaders, shape the public conversation, and push the boundaries of the science for public good. The challenge areas that we cover at the Turing include the application of data science and AI to health, engineering, security, economy, fair, transparent, and ethical algorithms, digital humanities, and government innovations. In this case, the Turing Way is well positioned at the Turing because we apply a crossing view on all data practices. And in the Turing Institute, we have this tool practices and systems program that is one that is like in somehow hosting the Turing Way, and it allows this program aims to recall the best practices across Turing research and teams, and try to deliver trustworthy system, transparent reporting, inclusive, interoperable design, ethical integrity, respectful cooperation, and leadership in open research. Now let's move to the content of this initiative of the Turing Way. All started when it was founded in 2018 with a guide as a reproducibility, and it was initiated by Kirsty Whittaker, that is the director of the TPS program at the Turing. And we start with contributors, we start adding content about best practices, recommendation, and they are start adding here, and you see in the figure in the left panel, different chapters that includes topics like open research, version control, data management, code testing, and reviewer. And at that moment we were thinking that were enough, but that wasn't. Research also includes like how we communicate with others, how we design our project, how we efficiently collaborate with each other. So that's why the Turing Way also have another guides in project design, communication, as we see what the previous speaker was saying, how we communicate not just to the research like as a researcher, but also like different kind of open ways to communicate our research. Collaboration, that is a case is very important to say that this Turing Way won't exist without the collaboration. We also cover ethical research, and we have a community handbook where how we can translate this content to other communities. Okay, and in terms of collaboration, I guess Turing Way, we have these ethos about collaboration, and it's a way that we are people usually thinking about coding. You think that the only way to collaborate in coding is that you need to know, you must know about programming skills, and not necessarily. The Turing Way is open. You don't need to have coding skills. You need to be an expert of topic. For instance, you can propose a topic, and we have a kind of experts that are in other different organizations at global level, and they help you with develop and sharing the content that you are proposing. The Turing Way is a work in progress guide that is always evolving, and that's why we have this maintain and improve. So everyone is welcome to contribute. You can share these resources about Turing to different networks that you have. They are open. People can review and update content. Very important here about making global. I am one of the translation leads, and we are applying technologies how to translate this content to other languages, and that's very important to be more inclusive. And finally, share best practices. Okay, so for this particular talk, I think was very relevant to show some impact of the Turing Way in different kind of initiative or sectors. So that's why I'm gonna present 3 use cases that are, of course, the impact go beyond to these use cases, but I just want to highlight some of them. So the first one is the environmental data science book that I am leading at the Turing, and all start because I'm working with climate and environmental scientists, and the same problem, like how in my team we can communicate the results and how they can be reproducible, not only for my team, but to others. So that's why I started this initiative about based on the community-based model similar to the Turing, how people can reproduce their research through executable Jupyter notebooks. So in this initiative, we have published around 10 notebooks where people are showing how the research can be reproducible, models, data, whatever. And at the moment, we are trying to use everything in Python. And what we learned from the Turing was about the community aspect and translating some of these theoretical fundamentals that you can find in the Turing Way to more practical like applications. You can access here through the QR or the links below. The other initiative that I would like to highlight is to I2C. They are also part of the Turing Way community, and maybe you are familiar with Jupyter Hub, Binder, all these efforts to try to communicate data science that people are using very actively. So I2C was funded by some of these core teams that were developing Jupyter Hub and some resources about Binder. And essentially what they're doing is to make interactive computing more impactful through community-centered open infrastructure services. They are more no-profit based model, and they are defining the kind of service that they are providing. They say that it's more open source operation, DevOps. And it's very interesting here because they're trying to democratize that this kind of Jupyter Hub, Binder, or whatever, like interactive computing is interoperable with all the kind of cloud providers that you can find, like Google, Microsoft, Amazon. So that's very exciting. But in terms of the Turing Way, that what they have been adopting is like about emerging roles that you can find in academia and in other sectors, like that sometimes as researchers we say, okay, research is only a knowledge to the PI, to the postdoc or students, but there are some people that play a huge role in research, like engineers, product manager, community managers. So they are defining these kind of roles with the Turing Way, and also they are adopting practices about transparent communication. So everything about open science. So they are trying to adopt these practices from the community and book in general. Finally,
one more minute. Yep.
I am highlighting the Turing Roche strategic partnership that is very important, and it's just you can go to the link. But what essentially we are planning here is that people in the industry start sharing practices in the Turing Way, and what this project in particular is doing as well is translating this kind of good practices from the Turing Way within the health industry. The impact go beyond to these projects, as I told you. Then later you can go through this impact, but they've been referenced in the hidden ref competition, and it's been used for learners, educators, community builders, policymakers. This won't be possible without the community, contributors and users. There are more like 3,300 contributors, and there is a plenty of history behind. From 2018, it's been growing the content to the present. And you can get involved, as I say, if you want a programming skill, you can join to the community events. We have collaboration cafe, co-working calls. These nice illustrations that I showed you before, we have everything in Zenodo, almost at 11,000 downloads we have of this illustration. You can contact us through GitHub, through email, through Twitter, Slack, and you are welcome to participate. And thank you, everyone, and especially Christy, the leader of this project, the colleague Malvika, and our communication manager, Anne, and all the Turing Way community. You can contact us through these different communication channels. Thank you.
Brilliant. Thank you very much, Alejandro. That's brilliant. And if you have any questions, please please put them to the chat. Yes, I'm excited to announce the last speaker. So this will be Professor Peter Grindrod from the University of Oxford, who I'll just give you a little biography here. So he's Professor of Mathematics at the University of Oxford and the former President of the Institute of Mathematics and its Applications. Founder of 3 successful analytics companies in sectors ranging from retail to energy supply to digital media. And in 2005, Professor Grindrod was recipient of the Commander of the British Empire for services to mathematics. He's also been a member of numerous research councils, including the EPSRC and BBSRC, and is former Minister of the Ministry of Defence Scientific Advisory Council. So I'm happy to introduce the final speaker on energy research, a two-way misalignment.
Hey, good morning, everybody. Thanks for asking me to come along today. Great talks to listen to. So where are we going with this? Well, Winston Churchill said about the British and the Americans, we were divided by a common vocabulary. And I think that's often true of universities and industry. And I'm going to explain why and maybe suggest how we can get around that. Actually, arguably, Winston Churchill said, never waste a good crisis. And we're in the middle of a couple of crises at the moment. One in energy and energy pricing and help for particularly domestic consumers, and one in the impact of data science and AI, which is running at very different speeds in different sectors. And I'm going to explain some of the problems that we've had with that. I'm actually a founding trustee of the Alan Turing Institute, and we do some things very well and some things not at all. So there's ground to make up on all sides. There's a two-way misalignment between industry and academia, and generically, the biggest problem is what I call the impedance problem. Industry invents and resolves problems on, say, a 3-month to 6-month timescale. Things bubble up, they need sorting out, and they have to be sorted out. Spent 20 years of my career doing that sort of thing. Academia likes 3-year timescales. It's 3 years for a PhD, it's 3 years or so for a postdoc position, that kind of thing. You know, in universities, we're not very good at dealing with things on short timescales, and there's a way around this, and I'm going to suggest that at the end. But clearly that is a fundamental stopper, and if you talk to many big companies, they'll admit that they've got projects with their universities in their own countries or their own regions, and they've lost interest in it, but they've got to keep flogging on. So they give somebody who's near to retirement the task of just managing the University of Woolacombe through to the end of the project, and everybody intellectually moves on within the company or the sponsor, whatever you want to call them. It's an impedance problem. It's a timescales problem. There's an access problem, a data access problem. What a load of nonsense we had trying to get hold of smart meter data and things like that. For years, people like Steve and myself were using the Irish smart meter data set, and Ofgem were just failing to compel people, the players, the networks and the suppliers in the UK to publish clear data from substations and particularly from smart meters. And now we've run into the case where no one really understands why there's a smart meter data, where the smart meter rollout, where the advantages are, and yet it could have all been very different. We could have had smart forecasting right there operating in the home now. We could go to time of day tariffs. We could be saving people a lot of money, and we aren't. And it's urgent that we sort this out. Interestingly, because of the energy crisis, the marginal value of saving on energy has now become so great that a lot of things that were thought to be marginal before are actually quite mainstream now. Has that changed the way that the R&D works in this sector? Have they woken up to that? That's the access problem. There's a proprietary data problem too. You know, a lot of the stuff we hear from institutes which are publicly funded have this obsession with open data access and things like that. And it's important for research that things are reducible and things like that. But that's a big no-no to many companies. They guard their proprietary data, particularly because they don't know what it's worth. They don't know what can be discovered from that. And I think we need a more nuanced and a mature approach to sharing data. Of course, over the last 10, 15 years, we've seen the growth of Kaggle competitions, which effectively puts data out there, and then it leverages an immense amount of effort from people competing. Actually, Steve and I back in the day took part in a Kaggle competition and did very well in it. But the point was that was a ready source of data. And we've seen in other areas of science and technology, like bioinformatics and the square kilometre array and things like that, when data is made available, then university groups all over the world get around it and start to put in effort. It doesn't necessarily mean funding. And you can be overfunded in academic research. But this is a failure of access to data, really. There's a risk problem, and this is a shared problem. You know, many companies, they have shareholders, and so they get solutions which are good enough. I often say it's catnap, cheapest available technology, narrowly avoiding prosecution. We've got a solution. Why do we want a solution to challenge that? And of course, that's thinking within the current paradigm. And while you're thinking within the current paradigm, somebody else, one of your competitors, is going to come and change the game. And then you're caught flat-footed. And who are you going to call at that point? Where are you going to get expertise from? Companies need an open innovation network, and that includes small companies, SMEs. It certainly includes universities, and maybe not the obvious departments in the universities. So you need people like Annette who are going to sort of show you around and get you to points within the university networks that you didn't even know you were going to need. There's a culture problem. Companies with an engineering culture are very proud of the fact that the lights don't go out and that supply takes place and all of this sort of thing. But actually, that's not so helpful when we want to do things differently, or we want to try and take some risks. You know, I often think that energy companies are very keen to show off to Ofgem how good they are at project managing. And they've almost prioritized project management over project innovation. I know they'll all say that's not true, but they're in denial. They have to show that they're spending money wisely, and they have to show that they're doing a good job with those projects. But in doing that, they don't understand that occasionally people in universities give a lot of value by going back upstream into TRL1, TRL2, things that weren't really immediate, but actually could be game changers. And this is an inbuilt bias against taking risks and making game changers. I think there's also a resilience and vulnerabilities problem. Partly the catnap thing produces single points of failure. So if everybody's using the same technology, if it goes wrong for somebody, it'll go wrong for everybody. And you can argue, well, we haven't been outperformed by our competitors, but that hardly helps the nation or helps the consumers. So the energy sector needs to get alongside the research sector and really look at new ways of doing things that challenge the conventional thinking. Is there a fear of the new? Is there a failure to embrace new technology? Now, of course, a lot of these criticisms could go into any sectors, but in data science in particular, the pace of change is so fast that these things are all felt to the power n, a very large number. The sheer pace of data science change, the rollout of AI, really that should be changing whole sectors. But if you mark the homework of the energy sector, I would say that, you know, there's been a certain resistance to doing it. There's a resistance to using social media data to find out what happens during power cuts. They just think that that's all about just trying to communicate better, but it isn't. There's real information about what went off when and where, and the order that things went off and things like that. What can we do about this? Well, I think that both sides have got to stop taking a project focus, a problem focus, and they've got to move to a sort of relationship management focus, so that companies interact with academia, and the academia guarantees to the company that they'll show them around different parts of academia, maybe departments they don't even know they need to talk to. And in return, the company needs to show the academics around to different parts of their company and different styles of problem and things like that. So that rather than having project managers arguing it out and arguing over the cake, actually you have a relationship managers on both sides that argue about where the cake is and what it might look like in the future. This is really, really important. So like Churchill said, never waste a good crisis. We've got a number of crises taking place at the moment. And I think it's time for both the industry and academia side, when we talk about energy and particularly we talk about data science, to come to a much more nuanced approach, and not to scare each other with their, insistence on certain practices, insistence on open data and things like that. And we find a much more grown-up way to share the problems and to find radical solutions. They're going to be exportable for the UK, and they're going to be better than the solutions in any one of the other European countries. Thank you very much, everybody.
That was brilliant. Thank you very much. So yeah, put some questions in the chat, Pete, please, for Pete. And now we're just going to have a few questions for all our speakers. So maybe if all the speakers could turn on their cameras. I've got questions here. So first, starting with Sam. So we have a question about, so how can someone, if they've not already programmed that set of code, can they understand it and the intent of the program? Is it not easier just to start from scratch?
I hope not, in the sense that so long as the person that is writing the code has good coding skills, they should be able to communicate their intent. And then again, if the person reading the code has sufficient coding skills, they should be able to pick up that knowledge that has been put down on the table. So it's all about making sure that we can get to that foundational level of skill in programming, software engineering, whatever you want to hear it, that allows that communication to happen really easily.
Thank you very much. Annette, we have a question about, so a lot of these conversations about communication and language seem to also dip a lot into pedagogy and ideas around how people learn new things. How much do you think academics research could benefit from learning about this, not just for teaching, but for disseminating new ideas clearly and effectively?
Yeah, so first of all, I've been thinking about this. It's the answer. This is a question right in the chat. I think it's a really good question. I'm kind of going to hold my hands up and say, I'm sure that academics do get some grounding in pedagogy as part of their kind of professional development and, and training in how to deliver teaching. And I think for me, we have to be careful about not asking, especially with current workloads, right? Not asking people to do loads and loads of new unless you can offer a real reason for people to do it. And I think thinking about how you might communicate the relevance of that original teaching, and saying, well, this is useful for communicating with students, but also don't forget this will be useful when you want to embark on a new collaboration. So don't just think about it in those terms, but also maybe like little bite-sized refreshers that people can pick up really quickly. And the other thing I'd also say is, and I'll say it again, a collaboration is all about relationship. And it's a two-way thing. And so there is a responsibility on the part of the both parties in a collaboration, or multiple partners to to try and communicate clearly. And the other part of that, of course, is listening. And listening is not a thing that is taught well or practiced well. I think in probably both academia and industry. And so I think there's a whole load of stuff in there which could be unpacked. So I kind of agree, but I wouldn't want to impose loads more workloads onto kind of a very, very overstretched system. It's more about making people realize the multiple uses of the skills and the trainings that they're already giving.
Great, thank you. Alejandro, Julian says it's a great project. What are you doing to advertise it and make sure people who profit from it know about it?
Okay, so it's important to say that the project is very community-led, so that it started as open source. So thanks to that aspects, the project has been growing because we have a very active community, and we project to be global. So it's not just UK researchers like playing role in this project. And as I say, it's not Turing owned project. It's just very community led project. So we are trying, and we have very strong presence in the social media, and we are aligned with other communities like that are training people, like Open Life Science program. There are others about carpentry that are training people. And indeed, NASA, you know, the agency of space agency in the States, they are building a curriculum for open science, and most of the core members are for the Turing Way initiative. So it's a kind of way that we try to be engaged with other communities that are training and educating, but people who know about that is because we invite and we have very transparent channels, and I guess it's the main thing, like it's a community-based level. So it's the way that we communicate and have very active social network on that. Yeah.
Steve, I can't hear you. I don't know if anyone else can.
Hello. I'll repeat that. Can you hear me now? Great. Pete, what can you? Well, a question from Sam here. What do you think universities can do to adapt to work on a 3-month time frame, or do you think industry should focus on finding problems that are on the 3-year time scale?
Well, I absolutely don't think the latter. I think there are things that universities can do. We ran a very large collaboration with Emirates Airlines, during which we carried out sprints. We had fail-fast projects and all sorts of things that were really on quite short timescales. But at the same time, we allowed the researchers to do long-term stuff too. So I think this is about having a relationship where the company and the company are in partnership, and both sides understand in order to get good people, we need to hire people who are there long term and have their own research furrow to plough, working towards becoming independent researchers. But against that, they can give up some fraction of their time to doing these short scale things. So I think this just requires some careful thought about what that actually is. Of course, we can always suspend people from their existing funding, but at the moment, there's no real way to fund people, say, as postdocs in departments of information engineering or mathematics or wherever it happens to be, to fund them, and so that they're there as a resource to support this sort of collaboration. I think that's a different type of job. But certainly to say, well, some fraction of your year ought to be dedicated to sprints, to fail fast, highly collaborative, high risk projects, I think it's very exciting for early career scientists and technologists. So I wouldn't go away from that. Of course, the Turing has the luxury of some of this long-term funding, and that's what we wanted to do. But it's much harder in universities, and I think we need to, think about that. Because money's tight, we tend to predicate all the research money that's given out as if there's a PI, there's a known project, it's been through peer group review. So it's all consensual funding. And this is about having some people that are prepared to do their own long-term stuff, but then come and put their shoulders to the wheel in the short term and go and see if there are consequences or opportunities that are available. So this can be got around, but it requires some creative thinking on both sides. And it's not a trivial matter, and it doesn't fit easily into the sort of program-based funding that most universities are obsessed with. Most universities' financial systems really only work for research council funding. They can't really get their minds around other things, and the way they bill, the way that they put down assets, even the way they want a 6-month extension at the end of the project. You know, it's all based around research council funding, and it's comical when they try and put a industrial relationship into that mix.
Thanks. Yeah, Annette, I think you put your hand up. Have you got a comment on this?
Oh, wrong button there. Fat fingers. I'll just keep talking. So I agree with a lot of what Pete says, and I was just going to say that, I mean, it's not a data science project, but one of the N8 programs had explicitly kind of the thing that Pete was saying, knowledge exchange fellows, where we had a pool of postdocs to do this kind of thing and have their own program. I think the issues were, you know, career paths, and, you know, that they felt, some of them felt, you know, again, in academia, you know, what's the career path for me? You know, will I get the recognition for the industrial impact work that I'm doing compared to, should I be spending my time writing papers? So I do think in the context of, you know, perhaps looking at what comes as the next version of REF, making sure that, you know, we understand potential career paths. I think that was part of the challenge for those at postdoc level, those with kind of senior academic, you know, those with an academic post in some respects are more secure. You know, they want to get their promotions, but at least they have the permanent post. And I think for postdocs who want to be academics or don't necessarily understand the opportunities in industry, there are, you know, there are conflicting pressures on them. That was all I was going to say, really. But there are ways and means of making it work within the UK funding system. It's just filling those posts can be a challenge.
Great, thank you. I think we've only got time for maybe one more question each here. So if there's any questions we don't get to, maybe the speakers can answer them in the chat. So I'll go back round to Sam. So we had a question about take database skills as an example. Can you comment on what's the most desirable database skills for the industry, or at least I guess for yourselves? But...
I could, but I might not, anticipating that we would run out of time. I answered that question in the chat already, so feel free to jump in there. There was another question from
there's a skills gap question.
Yeah, so from Julian about whether the skills gap is on the coding side or also the tech stack side. And the answer is a very big both. So frankly, if a student is doing a master's in data science or some other data-centric coding heavy in industry masters, and they get to the end of it and they don't know how to use Git or what Git is, and if they don't know any software design principles, then they have been let down by their university, right? They have not been given the skills that they need to try to get ahead in a market that is absolutely saturated on the entry level, and you need those critical skills to try to get your foot in the door. So there's definitely massive gaps on both. In terms of the solution, I'm not expecting academics, especially people that are very heavily into industry, to keep up with the latest and greatest in industry. I do expect better, you know, coding skills getting taught in university, but the solution is simple. You can have a coding skills course that actually focuses on that, and then reach out to all of your industry partners, get them in for guest lecturers. It's what I've done for a few places. And then we're very happy to come in and say, okay, you've been given some base skills. This is what it looks like when you would apply them in an industry context. So if we jump to the database example, maybe these poor students have been shown what to do with Microsoft Access, and we need to scrub that knowledge from their brains because it's terrible, and say, hey, if you do work in industry, you might be using something like Postgres, and this is how you can run it yourself, or this is how we would in industry utilize a database like this. So there's that disconnect, not just in keeping courses relevant to the skills that they need, but then getting that continual feedback from industry to keep them modern and fresh.
Great. Thank you very much. Annette, I know you've already answered really 2 questions, but there's an interesting question here about, you were mentioning about sort of, you know, industry not being frightened to talk to academia, but sort of, I guess for more junior members of academia, you know, they haven't necessarily got industry partnerships, but they wish to build them. Maybe you can talk a little bit about, you know, how they might build relationships, because often it seems it's more from the sort of PIs and lecturers where they have the relationships, but if not, how does a junior researcher or student?
Yeah, so I think, I mean, I in a way, I think the pandemic really helps us in this, because there are lots of events like this one, and others where you can rock up and listen to people speaking, and then potentially follow up with them outside. So I'm pretty sure most of the speakers here would not be averse to somebody, getting in touch with them and saying, oh, I met you, I'm, was really interested in this, that, or the other. So I think that's, one very direct way of doing it. And then I think then, the energy systems catapults, all the catapults, right? That's literally their job, right? And so I think that there's this kind of soft infrastructure in the UK research system, research and innovation system, which can help you. I also think generally there's lots of now, I would say EPSRC, but UKRI funded networks and network pluses, which involve academia and industry. Find one of those that's interesting to you. Go and talk to the person who runs it. They're desperate for help usually, offer to get involved, get engaged. I mean, people who have a bit of time to get engaged and enthusiastic and passionate are absolute godsend to some of the people that are trying to make these things work, and thereby you can kind of again broaden your network. So that's, I guess, just off the top of my head, that's a few ideas, but yeah, there you go.
Brilliant, thank you very much. Alejandro, there was a comment made by Robbie Morrison about sort of any open energy modeling community. And so it'd be interesting to hear from your perspective, maybe about, which countries are sort of quite ahead in terms of, open science, I guess, open data and open, these sort of practices.
Okay, maybe I guess in terms of country, in my domain that is about geoscience, I would say that the US, and I mentioned one community was Pangeo, it was in my slide, and they are basically a community that is developing software in Python, mostly about XRA, something about distributed computing, and it's trying to democratize this in open manner, like doing big data geoscience analysis. And it's one example, and I guess the community in US in general is very big and very into these open modeling frameworks. And one example is about this other NASA initiative about training people about open science and modeling skills, and they are targeting almost 20,000 people in general knowledge about this. So I found that it's very exciting what they're doing there. But the Turing Way is a global community, and we are collaborating with other people, and that's why we have this translation team that is aiming to be inclusive in other areas of the world, because we see usually this the global south and global north, like sometimes these inequalities are not good for industry people. There are other industries in my home country, Colombia, that they are not aware about these resources of the Turing Way, how we can maybe with the researchers there that are not trained in open science, how we can help them. So thanks to these translation efforts, they can make impact. So I think that is key to having these open resources like the Turing Way available and open manner to everyone. Yeah. So yeah.
Brilliant. Thank you very much. And so last question, Pete. So we were talked. There was a question about open data here. We've heard a need for greater data access and quality, but also the demanding data being open is an impediment to collaboration. How do we balance the two?
Well, it's tricky because if we look at some sectors like retail, for example, we don't routinely meet Sainsbury's basket data or Tesco club card data or things like that because we're not sure what's in it. There's also a security issue. But nevertheless, the lack of well-curated and available data sets where we can compare, for example, forecasting methods or inference methods or in generating different types of insights and things like that is really holding this back. I think it's not really about having, regulations that demand that data is open. It's about having proper collaborative environments where data can be shared responsibly and in a good way. You know, there are very many data sets around the world, for example, you know, cognition or brain scans or things like that, where you have to be a fit and proper person to access the data. I've recently got some data on online harms, and not everybody can have that data. You have to explain what you're going to do, how you're going to do it, and be relatively open about your mission in terms of it's not difficult to do, but I think that, you know, that would be a lot more help for our university departments and our institutes like Turing and things like that, because we could gain direct access in a responsible way to the data. You know, we're not there to try and, you know, pull the pants down of the industry and expose all sorts of egregious things in the data. Actually, we all want to try great ways of analyzing it, new ways of taking inferences, new insights that become, and that's the fun of data science. So I think this can be got around, but, you know, the push for transparency and open access isn't always, that message isn't always received by companies in the way that's maybe it's meant by the social scientists and the people who are running things on the university side. So I think we just need a more grown-up conversation. It's not a it's not a stopper, but it can be a barrier.
Brilliant. Thank you very much. I think we've run out of time, but you know, I've really enjoyed this, and I wish we could talk for a lot longer. But yeah, I just want to say thank you to everyone who's all the speakers today who've really given brilliant talks on a diverse number of topics, and we've had a great debate here. So the last thing here is just that, you know, please check out the reports and all the links and the outputs from all our speakers today. We'll put this up online shortly, and probably in the next day or two on our YouTube channel. We've put that link in there as well. So yeah, I just want to say thank you to everyone, and yeah, I hope to keep up with what everybody's doing.